This is JMS students and welcome to Homework 2.18 Unit 2 Test Prep. We will have our Unit 2 test next week to kind of cap off Quarter 1. So this homework is due Monday, and please make sure that you're showing all work because these are the type of problems that you could see on part of your test. So which comparisons are true? Remember, you want to put this note down. The further left a number is, the smaller it is. All right? So negative 10 is less than 10. That's true because negative 10 is further left. 8 is less than negative 8. That's false because negative 8 is further left. Negative 11 is less than negative 14. Again, that is false. Think about why. Again, if you had a number line, you'll have negative 11 right here, and then negative 14 would be further to the left, right? So negative 14 is smaller. Negative 20 is less than negative 13. That's true because negative 20 is further left, and negative 12 is less than negative 5. Also true, again, because it's further to the left. Number 2, the absolute value of negative 5 plus the absolute value of 34. Remember, absolute value is always positive, so the absolute value of negative 5 is 5 plus the absolute value of 34 is 34, not negative 34. So your answer there is 39. So put it on the answer line, please. Now explain why negative 7 is actually bigger than negative 8. Well, you could just say negative 8 is further to the left on the number line, so it is smaller. You could also say negative 7 is closer to 0, so it is bigger, right? Number 3, let's order these from greatest at the top to least, right? So the most negative is going to be your smallest, and then the least negative is going to be your largest. So let's see, the most negative, we want to go greatest to least. So the least negative, the closest to 0, negative 21. So negative 21's gone. And then negative 49, and then I'm getting more negative, right? Negative 64, negative 74, negative 89. So that's our order from greatest to least. Negative 21, negative 49, negative 64, negative 74, negative 89, right? Number 4, I'm going to let you, well, SSAK, same signs. Oops, I just wrote same signs, add, keep, and this should say DSSM, sorry, different signs, subtract more, right? Keep the one that is more. So for here, let's use keep, change, change. So remember, we only do it when we see subtraction. So it's a 1 minus sign, so plus a negative. Minus a negative would become plus positive. So this would be 5 plus negative 10, which equals negative 5. This would be negative 3 plus positive 10, which is equal to positive 7. What type of problems do SSP or DSSN? We haven't learned these yet, but this is for multiplication and division. This is what we're going to be doing next week. So multiplication and division. This stands for if they're same signs positive and different signs negative. But again, we'll learn that next week. So, number 5, all the following terms are examples of what vocabulary word? Negative 2 plus 2, or 2 plus negative 2 is 0. Negative 3.1 plus 3.1 is 0. Negative 3/4 plus 3/4 is 0. Opposites add up to 0. Oh, that's called the additive inverse. Opposites add up to 0. Okay. Number 6, let's match each subtraction expression to its equivalent addition expression. So let's first change the subtraction to addition. So minus sign, we have plus a negative, plus a positive, plus a positive, plus a negative. Now let's match them up. So negative 8 plus negative 9, that's this one right here. Boom. And negative 8 plus positive 9, that's this one right here. 8 plus positive 9, that's this one right here, and obviously 8 plus negative 9, that's this one right here. All right. So if 5th grader is confused by why negative 7 and 7 both have absolute values of 7, can you explain what absolute value is? So basically you can say absolute value is the distance a number on the number line is from 0. Distance, or space you could say, is not negative. Right, so here, draw this out. Here's 0, here's 7 over here, here's negative 7 over here. This is 7 spaces away from 0, and this is also 7 spaces away from 0. So the distance is never negative, right? Jeremiah wrote the following problem. The original problem is negative 5 sevenths, 5 and 5 sevenths plus 8 plus negative 3 and 2 sevenths. He rewrote it as negative 5 sevenths plus negative 2 sevenths plus negative 5 plus negative 3 plus 8. What mathematical property did he use to rewrite this? Obviously, this is the commutative property of addition, right? A very helpful commutative property. All right, let's flip over to the back. What do we have to do before trying to solve this problem? Negative 2/5 plus 7/8. You have to find common denominators, because you are adding fractions without common denominators. Okay, so gotta find common denominators first. Convert to an improper fraction. Obviously, this one's simple. It's 5 times 3 plus 5. Or, oops, nope, messed that up. 5 times 3 plus 15, which gives you 16 over 3. And then convert to a mixed number. We have 11 over 3. That's when you divide 3 into 11. Notice we only do this when the numerator is bigger than the denominator. So 3 goes into 11 3 times. 2 left over. So 3 and 2/3. And now for this last section, guys, all you're going to do is tell me the type of problem it is and then the answer. So for instance, 15 plus negative 6, that's a DSSM. So you're just going to do, all right, 15 minus 6, because different signs subtract. Obviously that gives you 9, and my answer is positive because I had more positives, so 9. For something like 12, you want to, it's a subtraction sign, so keep, change, change, right? So that just becomes 9 plus 8, so it's an SSAK, so then you just say 9 plus 8 is 17, keep the positive sign, right? So then 17 is your answer. So you only do KCC with subtraction. So for instance, here, would you do KCC? Yes. Negative 12 plus positive 8. Would you do KCC here? No. No, because you have a plus sign. KCC here? Yes. 9 plus negative 17. KCC here? No. You have nothing but plus signs. Right? On this one, you actually might want to rewrite it as negative 5 plus negative 10, and then plus 4 plus 7, using the commutative property of addition. So adding those two together first, and then adding these two together first, right? Here, do you want to use KCC? Yes. You want to keep, change, change, plus a negative, plus a positive, leave that alone, plus a negative, right? So notice how we left the plus sign alone. So you can rewrite this as 7 plus negative 9 plus positive 3 plus 8 plus negative 5. Then you might want to rewrite it again as negative 9 plus negative 5 plus 7 plus 3 plus 8, right? Then you can add the negatives, add the positives, and then you're down to a DSSM, right? Same thing here on 16. After you add the negatives together, that's negative 15 plus positive 11. That's a DSSM. You got to solve that. So DSSM here as well. First, you have SSAK, negative 14 plus 7 plus 3 is 10. So plus 8 more is 18. Now it's a DSSM, right? And then for 19 and 20, you want to make sure that you find common denominators here. So let's say times 4 times 4 times 5 times 5. So you have negative 8 over 20 plus 35 over 20. And that's obviously DSSM, different signs, subtract, keep the sign that you have more of. I'll let you solve that. And here you want to split them up. So 3 plus 1/5 plus a negative. So plus negative 5 plus negative 3/5, right? So then you want to say, okay, 3 plus 5 plus 1/5 plus negative 3/5. This gives you 8, obviously, plus 1 plus -3, DSSM, -2/5. Can't slap them together. This is where you have to borrow, right? So you have 7 plus 5/5 plus -2/5. And that's a DSSM, right? So 5 plus -2 is 3. Different signs subtract. So 7 and 3/5. So I did a whole lot for you in hopes that you can have a really productive weekend and get any missing assignments done in other subjects. Call me if you have questions.